Welcome students. In this class we will be studying how exactly we can use inverse Laplace transforms for solving application-oriented problems. However, though this topic comes under differential equations, yet I thought it would be much better to also include this with the Laplace transforms. Of course, this is being featured with inverse Laplace transforms so that you can have an idea where exactly these transforms are being applied. So we got the differential equations: y triple dash positive 2 times y double dash negative y dash negative 2 times y is equal to 0. Given that y at t is equal to 0 is equal to y dash at t is equal to 0 is equal to 0, and y double dash at t is equal to 0 is given to be as 6. So first step, what we will do is we will be taking Laplace, taking LT on both sides. We get, so this is going to be Laplace transform of y triple dash positive 2 times y double dash negative y dash negative 2 times y is equal to L of 0. So L of, in fact, by linear property I can rewrite this as L of y triple dash positive 2 times L of y double dash negative L of y dash negative 2 times of L of y is equal to 0. Now L of y triple dash, now this is equal to s cubed of L of y negative s squared of y of 0 negative s of y dash of 0 negative y double dash of 0. So this is going to be the formula. So we can state here that we know that L of triple dash is this. L of y double dash is going to be s squared of L of y negative s of y of 0 negative y dash of 0. Now L of y dash is s L of y negative y of 0. So these are the formulae we have already come across. So what we will do is we will use these formulas in 2. So therefore 2 can be rewritten as, I would be substituting s cubed of L of y negative s squared of y of 0 negative s times y dash of 0 negative y double dash of 0. So this is for this, positive 2 times L of y double dash. So this is going to be s squared L of y negative s y of 0 negative y dash of 0, followed by negative L of y dash. L of y dash is s times L of y negative y of 0, so followed by negative 2 times L of y is equal to 0. Now if you were to see the question, y of 0 is equal to 0, y dash of 0 is equal to 0. So we can state that since y of 0 is equal to 0 and y dash of 0 is equal to 0, now what happens here? Y dash of 0 cancels, y of 0 cancels, y of 0 cancels, y dash of 0 cancels, y of 0 cancels. So we need to write the remaining. So this would mean we got s cubed of L of y followed by negative y double dash of 0 positive 2 times of s squared of, that's the only thing remaining, L of y, and then negative s times L of y negative 2 times L of y is equal to 0. So this is what we have got. Now y double dash of 0 is given to be as 6. So we can state that since y double dash of 0 is equal to 6, if I were to take this as say 3, So therefore 3 can be rewritten as, so I just retain it as it is, s cubed L of y, negative y double dash of 0 is 6, positive 2 times s squared L of y, negative s times L of y, negative 2 times L of y is equal to 0. Now what I'm going to do, I'm going to take L of y common. So this is going to be L of y times s cubed, positive 2 times s squared, negative s, and I've got a negative 2 there, and I've got a negative 6. I can take this negative 6 onto the other side, so that would mean 6 would occur there. So this is what I've got. So this would mean L of y is equal to 6 divided by s cubed, positive 2 times s squared, negative s, negative 2. Now we will have to factorize this. Now the best way to factorize this is by synthetic division. So since 2 is present in a constant term, we can make a choice by using guess and check technique. So the factors of 2 are plus 1 minus 1 plus 2 minus 2. So what I will do is I will take negative 1 as a choice. I'm trying to factorize this. So the coefficient of s cubed is 1, the coefficient of s squared is 2, coefficient of s is negative 1 followed by negative 2. Of course there are various other techniques by which we can zero it in and by several laws available, but that is beyond the scope of this particular question. So I just wanted to make sure that I'm able to achieve the requirement of getting this factorized. So bringing 1 down, 1 times negative 1 will give me negative 1, adding these two will give me 1, negative 1 times 1 would give me negative 1, negative 1 added with 1 will give me negative 2, negative 2 times negative 1 will give me positive 2, this is 0. So clearly this, I can clearly see that s is equal to negative 1 is a factor. I should say is a root. S is equal to negative 1 is a root. So this means s positive 1 is a factor. So I can see that this is a factor. So now we can factorize this. So the quotient in this case is, we started with s cubed. So this is going to be s squared, positive s, negative 2. This is what we have got. Of course, you can further factorize this. What I can do is I can use the technique of factorization and rewrite this as s negative 1 times s positive 2. So you can check this out. S into s will give you s squared, s into 2 will give you 2s, s into negative 1 will give you negative s, negative 1 into 2, positive 2 will give you negative 2. So this is going to be s squared, positive s, negative 2. So that's simple. So now what we need to do is we need to take all of this and place this here. So L of y, so therefore we have factorized the right side. L of y is equal to 6 over s negative 1 and then s positive 1 times s positive 2. So now we have to split this using partial fractions. So what I will do, I will rewrite this, consider 6 over s negative 1 times s positive 1 times s positive 2. This is equal to a over s negative 1 positive b over s positive 1 positive c over s positive 2. So if you were to cross multiply, this is going to be a times of s positive 1 times s positive 2, positive b times of s negative 1 times s positive 2, positive c times of s negative 1 times s positive 1. On the left side I got 6. So clearly I can take the value of s to be as negative 1. If s is equal to negative 1, this will vanish. S is equal to negative 1, this will vanish. S is equal to negative 1, this will stay. So this is going to be, and over here all these things will vanish, so giving me 6. So therefore the value of b is 6 over 2 with a negative sign. So I can just retain it as it is. Now similarly I need to find the value of a. So I will try to use this space here. So if I were to substitute s is equal to 1, this will vanish, this will vanish, this will stay. So 2 times, this is 2, and this is 1, 3. So 3 times 2 is 6, right? So I am getting here 6 times a. 6 times a is equal to 6. So this is what I get. So therefore a is equal to 6 over 6. So which is equal to 1. I know that is equal to 1. Okay, but I'm just retaining it like that. So we have got that, and finally we need to obtain the value for c. Now if I substitute s is equal to minus 2, this goes away, this remains. So minus 2 means this is minus 3. So let me put that here. So it's going to be positive 3 times c is equal to 6. Therefore c is equal to 6 over 3. So I got the value for a, b and c. So I've got all the values. So what I need to do, I need to substitute these values here. So if you want to substitute the value of a is actually 6 over 6. So it's 1, but I want to write it as 6 over 6. So this is going to be s minus 1 times 6, and b is 6 over negative 2. So write it as 6 over s positive 1 times negative 2, and c is 6 over 3. So 6 over s positive 2 times 3. We can just get rid of these things. So 2 divides here 3 times, and 3 divides here 2 times. So it's going to be 1 over s negative 1. This is negative 3 over s positive 1. This is positive 2 times s positive 2. So this is L of y. Now we need to get y. So from here y is equal to L inverse of 1 over s negative 1. Negative 3, that's 3, right? So 3 over s positive 1, positive 2 over s positive 2. So this is what I've got. So now what I will do is, by linearity, I can rewrite this as L inverse of 1 over s negative 1, negative 3 times L inverse of 1 over s positive 1, positive 2 times L inverse of 1 over s positive 2. So by the shift, this is going to be e raised to the power of t. This is going to be e raised to the power of negative t. This is going to be e raised to the power of negative 2t, which is the desired result. Okay, so this completes the solution for this question, students. We'll move on to the next question. Welcome, students. We've been asked to use the transforms in solving this differential equation. The only thing is that instead of the usual y, we got an x here. So what I would do is I would rewrite this in the following fashion. So I get x double dash negative 2 times x dash, and I've got a x there is equal to e raised to the power of t. So I'm taking Laplace transforms on both sides. So this is going to be L of x double dash negative 2 times L of x dash, and L of x is equal to L of e raised to the power of t. Now this is going to be 1 over s negative 1. Now in this case, we have already seen that L of y double dash is equal to s squared L of y negative s times y of 0, and then followed by y dash of 0. So this is the formula that we have for L of y double dash. Now we will have to convert this for L of x double dash. So therefore L of x double dash will be s squared L of x negative s times x of 0 negative x dash of 0. Now if you were to see here x is equal to 2, that means at t is equal to 0, the value of x is given to be as 2. So this is going to be 2. So this can be rewritten as s squared L of x negative 2 times s x dash of 0. You can clearly see dx over dt is equal to negative 1. So what you can do is you can substitute the value of negative 1. So that means this is going to become positive. So this is what we have got for L of x double dash. So that is fine. Now we will have to move on in obtaining the transform for L of x dash. So for that we know that L of y dash is equal to S into L of y minus y of 0. So rewriting this for x dash, this is going to be S times L of x negative x of 0. Now this is equal to S times L of x of 0. X of 0 is equal to 2. So we need to substitute the 2. So we've got this, we've got this, we have got for L of x dash. Now we need to substitute it in 2. So therefore I can rewrite 2 as, I'm going to rewrite, in fact, okay, let me take this as 3 and place here 3, right? So I can rewrite 3 as L of x double dash. I'm going to have this as S squared L of x negative 2 times S positive 1. So that's for this term. Negative 2 times L of x dash. L of x dash is S into L of x minus 2. That's fine. So this has to be followed by negative L of x is equal to 1 over S negative 1. Okay. Alright, we've got this. Now there is a slight alteration we need to perform. Now the original problem says d squared x over dt squared negative 2 times dx over dt positive x is equal to e raised to the power of t. We are taking the Laplace transform of this. So in this case it's positive x, but I have placed here negative x, so it has to be positive there, it has to be positive there, and nothing of big change except for this positive sign being placed here. Apart from that, there isn't any big alteration that we need to do, so just for the sign. So now what I wish to do is I would like to rewrite this as S squared L of x negative 2 times S positive 1 negative 2 times S times L of x. Negative times negative is positive, for positive L of x is equal to 1 over S negative 1. So this is what we've got. Now what we can do is we can take L of x out, and that would mean I get an x squared here, negative 2s and a positive 1 there, and apart from that I got a 4 and a 1, that's 5, and then negative 2s, so negative 2s can be pushed to the other side. So this is going to be 1 over S negative 1 followed by positive 2s and 4 plus 1 5. We push the 5 to the other side to get negative 5. So this is what we've got. Now this is actually S negative 1 raised to the power of 2, right? So I can rewrite this L of x to be as S negative 1 raised to the power of 2. Alright? So if you were to expand this, you get S squared negative 2s positive 1. That's fine. Is equal to 1 over S negative 1 positive 2s negative 5. So I will have to bring this S negative 1 raised to the power of 2 to the right hand side. So let's do that. So bringing it down, I would get L of x is equal to 1 over S negative 1 raised to the power of 2. That has to be multiplied with this entire component. S negative 1 positive 2s, there's a denominator 1 followed by 5 over 1. So if I were to multiply that, I would get 1 over S negative 1 raised to the power of 3 positive 2 times S divided by S negative 1 raised to the power of 2 negative 5 divided by S negative 1 raised to the power of 2. So this is what I would have. What we need to do, we need to take the LCM and simplify. So I'm going to take S negative 1 raised to the power of 3. This is going to give me 1 positive 2 times S of S negative 1 negative 5 times of S negative 1, which can be rewritten as 1 positive 2 times S squared negative 2s negative 5s positive 5 divided by S negative 1 raised to the power of 3. Now negative 2s negative 5s can be added, 1 added with 5, so that's going to be 2s squared negative 7s positive 6 divided by s negative 1 raised to the power of 3. So this is what we have got. Consider the term 2 times s squared negative 7s positive 6 divided by s negative 1 raised to the power of 3. I want to split them in partial fractions, so I will write it like this: a over s negative 1 positive b over s negative 1 raised to the power of 2 positive c over s negative 1 raised to the power of 3. So you cross multiply, you get a times s negative 1 square plus b times s negative 1 plus c. On the left side you get 2 times s squared negative 7s positive 6. I want to get rid of a term, so I will take s is equal to 1. This will vanish, we're remaining with, we are left with c, but on the left side I get 2 and a 7 and a 6. 6 out of the 2 will give me 8, 8 negative 7 will give me 1, therefore the value of c was going to be 1. And now we can take the value of s to be as 0. So if I take s is equal to 0, I would get here a, I would get here minus b, I will have a c here, and then over here is 6, but my c is 1. So if I were to substitute 1 here and move that, so I would have a negative b is equal to 5. That's one equation, right? So let me take this as equation 1. Now I can take s to be as, say, sum 2. If I take s is equal to 2, this would give me a, s is equal to 2, this is going to give me a b and a c. S is equal to 2 squared is 4, 4 times 2 is 8, 7 times 2 is 14, positive 6, and this is going to give me 0. But my c is 1, so if I were to push it, I will have a positive b is equal to negative 1. So this is my 2, so I'll write that here. A positive b is equal to negative 1, so my bb gets cancelled, so 2a is equal to 4, therefore my a is equal to 2. My a is equal to 2, I substitute a is equal to 2, therefore my b is going to be negative 3. So I got the value of c, a and b. So if I were to take this as probably say sum 4, something like that, we can, therefore I can say, I can rewrite 4 as, 4 can be rewritten as, this entire component is rewritten like this. So 2 over s negative 1 positive of negative 3 over s negative 1 raised to the power of 2 positive 1 over s negative 1 raised to the power of 3. On the left side you got this, right? This is the term you got, but you have to, but this is nothing but L of x. This is nothing but L of x, right? So L of x is this, but we need to obtain x. So this would mean x is equal to 2 times L inverse of 1 over s negative 1 negative 3 times L inverse of 1 over s negative 1 raised to the power of 2 positive L inverse of 1 over s negative 1 raised to the power of 3. Now this is going to give me 2 times e raised to the power of t, that's fine, negative 3 times this. By shifting theorem you are going to get e raised to the power of t, but there is a s squared. So if it is s squared, we can apply the formula of t divided by 1 factorial, right? So this is going to be t divided by 1 factorial. You don't have to write 1 factorial. Positive, this is going to be e raised to the power of t, and this is going to be t squared divided by 2, right? We have already studied this in inverse Laplace transforms. So you get 2 times e raised to the power of t, negative 3 times e raised to the power of t times t. Of course, 1 factorial I have not written. You can easily understand that. Now if you want, you can rewrite, this is my solution. Okay, this is my x. So with this we can complete, or I should say we can stop over here. This is the right place to stop. Welcome students, we are expected to solve this question. D cubed negative 3 times d squared positive 3 times d negative 1 of y is equal to t squared times e raised to the power of t, with y being given at t is equal to 0 to be 1 t is equal to 0, y dash of 0 is equal to 0 and y double dash of 0 is equal to 2. Now what I would do is I would just start off the solution by saying given. So I'm going to rewrite the question in this fashion: y triple dash negative 3 times y double dash positive 3 times y dash negative y is equal to t squared times e raised to the power of t. Right, now I'm going to be taking Laplace on both sides, taking Laplace transform on both sides. We get, so what do we get? We get L of y triple dash negative 3 times y double dash positive 3 times y dash negative y is equal to L of t squared e raised to the power of t. Now first let us evaluate what is Laplace transform of t squared. So this is going to be equal to 2 factorial over s raised to the power of n positive 1, which can be rewritten as 2 factorial divided by s raised to the power of 3, right? Because in fact I don't have to write it as n positive 1, in fact it should have been 2 positive 1, but I just want to use the Laplace transform of t raised to the power of n, which is written as n factorial divided by s raised to the power of n positive 1. We need to apply the shift because we have been given L of t squared times e raised to the power of t. So that is going to be, the coefficient of t is 1, so we will have to subject this to the shift of s negative 1. So this is going to be equal to 2 over s negative 1 raised to the power of 3. So we have got the right hand side. Now the left hand side, by linear property, I am going to write it as L of y triple dash negative 3 times L of y double dash positive 3 times of L of y dash negative L of y. Of course on the right side it's 2 over s negative 1 raised to the power of 3. Now what I wish to do is I would like to use the formula for this. So what is the formula? If we were to use the formula for L of y triple dash, which we already know, it's going to be s raised to the power of 3 Laplace transform of y negative s times y of 0, of course the degree is 2 here, followed by negative s of y dash of 0 negative y double dash of 0. This entire thing is for L of y triple dash. Now followed by negative 3 times of L of y double dash, that's going to be s squared of L of y negative s of y of 0 negative y dash of 0, followed by 3 times of L of y dash, that's going to be s into L of y negative y of 0 followed by L of y. Of course this is equal to 2 divided by s negative 1 raised to the power of 3. Okay, now what are we given? Let me use this space. We are given that y of 0 is equal to 1, y dash of 0 is equal to 0, and y double dash of 0 is equal to 2. So y dash of 0 we have to get rid of that. So y dash of 0 is 0, this goes off, this goes off, anything else? Okay, that's it. Next, y of 0 is equal to 1 and y double dash of 0 is equal to 2. So we will have to substitute these values. So s cubed L of y negative s squared, y of 0 is 1, I don't have to place that, negative y double dash of 0 is 2, followed by negative 3 times s squared L of y negative y of 0 is 1, that's going to be s there, then followed by 3 times of s into L of y, negative y of 0 is 1, so I need to place that, followed by L of y is equal to 2 divided by s negative 1 raised to the power of 3. So So much so for that. So now what I wish to do is I would like to take L of y out. So if I were to take L of y out, I would get s cubed and followed by negative 3 times s squared, and then followed by 3 times s and negative 1. And I am being left with, so let me evaluate the quantities with s. So it's going to be negative s squared and negative positive 3 times s, and that's it. And followed by quantities with constant term. So it's going to be negative 2 and a negative 3, that's going to be negative 5, is equal to 2 over s negative 1 raised to the power of 3. So this is what we have got. So what we're going to do is we will have to do some simplification. So let's do that. So just make sure that you place this to be the implies sign. Okay, so everything looks fine. So what I'm going to do is I'm going to push everything to the right hand side. So this is equal to 2 divided by s negative 1 raised to the power of 3. This is going to be positive s squared negative 3 times s positive 5. So this is what will be the outcome. On the left hand side you got L of y. Now s cubed negative 3s squared positive 3s negative 1. This can be rewritten as s negative 1 raised to the power of 3. Now you can expand this. When you expand this, you get, this is actually a minus b whole cubed formula. So what is that? It's going to be a cubed negative 3 times a squared b positive 3ab squared and followed by b cubed. Right, this is the formula that we got. And before we could simplify this, we will have to bring the term down. So that is very much critical. So L of y, from here I can rewrite this as 2 divided by s negative 1. If I were to bring this down, it's going to be degree 6 followed by positive s squared negative 3 times s positive 5 divided by s negative 1 raised to the power of 3. So this is what I've got. So now what we got to do is we will have to do some simplification with the quantity over here. Now this can easily be simplified and solved, and for this term what I wish to do is I would like to rewrite s squared negative 3s positive 5 as s negative 1 raised to the power of 2. When I expand this, I get s squared negative 2s and positive 1. I get a negative 3s, so I need to get negative 2s, so I add a negative s. Of course I need to have a positive 5, so for that I'm going to add a 4. So I'm going to rewrite this like this. So this is equal to 2 over s negative 1 raised to the power of 6 positive s negative 1 raised to the power of 2 negative s positive 4 divided by s negative 1 raised to the power of 3. Now what I wish to do is I would like to use this algebraic quantities law. A positive b over c can be rewritten as a over c positive b over c. So if I were to use that, then I could rewrite this as 2 over s negative 1 raised to the power of 6 positive s negative 1 raised to the power of 2 divided by s negative 1 raised to the power of 3 negative s divided by s negative 1 raised to the power of 3 positive 4 over s negative 1 raised to the power of 3. Now what I'm going to do is I need to now take care of this. All of these things are solvable. In fact, I can take the Laplace inverse for this, Laplace inverse for this, but this is s, so I need to get rid of that. So what I wish to do is I would like to write this s as s negative 1 positive 1, right? So if I were to do this, I can safely rewrite this. Let us move to the next page, and so let me rewrite that. So I get L of y is equal to 2 over s negative 1 raised to the power of 6 s negative 1 raised to the power of 2 divided by s negative 1 raised to the power of 3
negative s divided by s negative 1 raised to the power of 3, positive 4 over s negative 1 raised to the power of 3. This is what I've got. So I'm going to rewrite this. So this is equal to 2 over s negative 1 raised to the power of 6, positive. I can cancel the degree 2 with the degree 3, so that is going to give me 1 over s negative 1. Negative, I'm going to write s as negative 1, positive 1 divided by s negative 1 raised to the power of 3, positive, this is 4 over s negative 1 raised to the power of 3. This can be further rewritten as 2 over s negative 1 raised to the power of 6, positive 1 over s negative 1. Negative, I'm going to rewrite this as s negative 1 divided by s negative 1 raised to the power of 3, positive 1 over s negative 1 raised to the power of 3, positive 4 over s negative 1 raised to the power of 3. This can be further rewritten as 2 over s negative 1 raised to the power of 6, positive 1 over s negative 1, and I can take this down with the outcome being 1 over s negative 1 raised to the power of 2, positive 1 over s negative 1 raised to the power of 3, positive 4 over s negative 1 raised to the power of 3. Now this is on the left, I got L of y. This is simplifiable. So now what I wish to do, I need to obtain y, so I will have to apply L inverse for all these terms. So it's going to be L inverse of 2 over s negative 1 raised to the power of 6. However, I'm going to take the 2 out here and write this as 1 over s negative 1 raised to the power of 6, positive L inverse of 1 over s negative 1, followed by L inverse of 1 over s negative 1 raised to the power of 2, L inverse of 1 over s negative 1 raised to the power of 3, positive 4 times L inverse of 1 over s negative 1 raised to the power of 3. Okay. So if you were to apply the shifting theorem first, so it's going to be 2 times of e raised to the power of t, and this is going to be L inverse of 1 over s raised to the power of 6, and this is going to give you positive e raised to the power of t. It's going to be s, L inverse of s is going to be 1, so nothing to worry about that, and this is going to be s negative 1 raised to the power of 2, right? So e raised to the power of t, L inverse of 1 over s squared, that's what we get, positive e raised to the power of t, L inverse of 1 over s cubed, and positive 4 times, this is going to be e raised to the power of t, L inverse of 1 over s cubed. Okay, so I can apply the L inverse for these terms. So this is going to be 2 times e raised to the power of t. This is going to be t power 5 divided by 5 factorial, positive e raised to the power of t, negative e raised to the power of t. This is going to be t divided by 1 factorial, positive e raised to the power of t. This is 3. So this is going to be t squared divided by 2 factorial, positive 4 times e raised to the power of t, and this is going to be t squared divided by 2 factorial. Now we can do the simplification. Now we can add these two things together, right? So if I were to take t squared out and 2 factorial out, and if I were to take e raised to the power of t out, this is going to be 1 positive 4, which is going to be 5 times t squared e raised to the power of t divided by 2 factorial. So this one is taken care of. And is there anything else? Okay, I can't do anything with this and this. I need to write them as it is. So what will be the solution for y? I start with the 2 over 5 factorial. Okay, and I will write t raised to the power of 5 times e raised to the power of 2 t, followed by t squared, that's the next power. So it's going to be positive 5 over 2 factorial and t squared e raised to the power of t, followed by negative t over 1 factorial times e raised to the power of t followed by e raised to the power of t. So that is going to be the solution. Now, however, e raised to the power of t is common, so what I can do, I can take that out. That's the only thing I can take out, right? So that would give me 2 over 5 factorial times t power 5 positive 5 over 2 factorial times t squared negative t over 1 factorial and positive 1, and this is going to be my y. So this is the final solution for this question, students. Welcome, students. We've been given this question: d squared x over dt squared positive 9x is equal to cos 2t, with x of 0 being equal to 1 and x of pi over 2 is equal to negative 1. Now this is a unique problem, and we will adopt a different approach to solve this question. And foremost, what we will do is I will rewrite the given question as x double dash positive 9 times x is equal to cos 2t. Next, what we will do is I will be taking Laplace transform on both sides. So when I do that, I get L of x double dash positive 9 times x is equal to L of cos 2t. Now, since by linearity I can always rewrite this as L of x double dash positive 9 times L of x is equal to L of cos 2t. So let me write it like that. Now L of x double dash, now we know that L of y double dash is equal to s squared L of y negative s times y of 0 negative y dash of 0. Now rewriting this for L of x double dash, this is going to be s squared L of x negative s times x of 0 negative s dash of 0. So if I were to take this as 2, I can rewrite 2, therefore 2 can be rewritten as, in place of L of x double dash I would be substituting this. So it's going to be s squared L of x negative s times x of 0 negative x dash of 0 positive 9 times L of x. Now cos 2t, that's going to be s divided by s squared positive 2 squared, that's going to be 4. Now this can be rewritten with the value. Now it's been given that x of 0 is equal to 1, so we can only take this over here. So this is going to be s squared L of x negative s times x of 0 is 1, so this is going to be 1, so s times 1 is going to be s negative x dash of 0. Now I cannot use x dash of 0 and solve because there isn't a x dash of 0. So what I'm going to do is I'm going to take x dash of 0 to be equal to some p. So this is going to be some p positive 9 times L of x is equal to s over s squared positive 4. Now I can take L of x out, so if I take L of x out I would get s squared here. I have a 9 here, so it's going to be positive 9. I want to move all these things to the other side, so this is going to be s divided by s squared positive 4 positive s positive p. Now I can move this s squared positive 9 down, so that's going to be L of x is equal to s over s squared positive 4 times s squared positive 9 positive s over s squared positive 9 positive p over s squared positive 9. Now you can use partial fractions, but I've got a technique for this. I'm going to show you this. Now I can rewrite s over s squared positive 4 times s squared positive 9 to be equal to s divided by s squared positive 4 negative s divided by s squared positive 9. Now if you were to take the LCM, s squared positive 4 times s squared positive 9, This is going to give me s times s squared positive 9 negative s times s squared positive 4. Now if you were to expand, this is going to give me s cubed. This is going to give me 9 times s negative s cubed. This is going to give me 4 times s divided by the denominator. Now positive s cubed negative s cubed goes away. 9s negative 4s will give me 5s divided by the denominator. The denominator here is s squared positive 4 times s squared positive 9. Now what I wish to show you here is, just without going through the tedious nature of placing or applying partial fractions, I am able to rewrite this quantity as this quantity. The only problem is this can be achieved if I were to place 1 over 5 here. So if I were to, so this is s divided by the denominator is equal to 1 over 5 times this entire quantity, because this 5 will be neutralized once I have a 5 there. That's exactly what I wish to show you. So all these things are for understanding purposes. So what I will do is I will start off by writing this term first. S divided by s squared positive 9 positive p over s squared positive 9 positive 1 over 5 times of this quantity s divided by s squared positive 4 negative s divided by s squared positive 9. So this is what we have got. Now clearly you got a s divided by s squared positive 9, and then you got 1 over 5 of s divided by s squared positive 4, and then you got a negative 1 over 5 times s divided by s squared positive 9. So we can do some clubbings, right? We can club some quantities over here and simplify them. So I'm going to be rewriting this with this. So this is going to be s over s squared positive 9. I got this term, so this followed by this term is going to be negative 1 over 5. I can write it like this. So this and this are clubbed, followed by p divided by s squared positive 9 followed by positive 1 over 5 times s divided by s squared positive 4. So this is what I've got. Now I've got a 9 here, so I need to do something in the numerator because of the presence of the 9 here. So before I could do that, I would like to rewrite this as 4 over 5, right? 1 negative 1 over 5 is 4 over 5 times s divided by s squared positive 9 is written as 3 squared. Okay, fair enough. Positive p times the denominator is s squared positive 3 squared. So if I have a 3 here, I can clearly apply the sine rule for Laplace inverse. So I need to multiply the numerator by 3 and divide it by 3, followed by, I don't have to do anything here, this is 1 over 5 times s divided by s squared positive 2 squared. So on the left hand side, this is going to be L of x. So I need to obtain the x. So x is equal to 4 over 5 L inverse of s over s squared positive 3 squared positive p over 3 times L inverse of 3 over s squared positive 3 squared positive 1 over 5 L inverse of s over s squared positive 2 squared. Now this is going to be 4 over 5 L inverse of s over s squared positive 3 squared. This is going to be cos 3t positive p over 3 L inverse of 3 over sine squared, 3 over s squared positive 3 squared. This is going to be sine 3t positive 1 over 5. This is s over s squared positive 2 squared. That's going to be cos 2t. Okay, so what is this? This is actually x. Now the right side it is all t, on the left side it is x. Actually x is a function of t, so we can always write it as x of t. But it is given that, what is given? This is given. It is given that x of pi over 2 is equal to negative 1. So that means the value of t takes pi over 2. So what we need to do, we need to extract the value for p here. So we need to substitute pi over 2 at these points and obtain the value of p. That's exactly what we are going to do. Now when I substitute t is equal to pi over 2, now pi over 2 is 90. This is going to be cos 270. Cos 270 is 0, so this will vanish. This will give me sine 270, which would mean the value of sine 270 is negative 1. So this is going to be negative p over 3. Of course, on the left side, x of t, when t is equal to pi over 2, is given as negative 1. So I need to substitute negative 1 there, followed by t is equal to 90. So that means cos 180. Cos 180 is negative 1. So I get a negative 1 over 5. Okay, so that's the value I get, negative 1 over 5. So I'm going to take all these things and use this space here. I hope you can watch this. So it's going to be negative 1 is equal to negative p over 3 followed by, so I can push this negative 1 over 5 to the other side. So if I were to do that, let me use this space here. So I get negative 1 equal to negative p over 3, negative 1 over 5. I push this negative 1 over 5 to the other side. It's going to be negative 1 followed by positive 1 over 5 is equal to negative p over 3. There's already two negatives, so they will become positive. So that would mean I'll have a positive 12 divided by 5. So this is the value of my p. Now the solution is complete only when you take this p is equal to 12 over 5 and then substitute it in the original system. So I'm going to use this space here. So this means, okay, therefore x is equal to 4 over 5 times cos 3t plus p is 12 over 5, but there is p over 3 here. So 12 over 5 divided by 3, so that's going to be 12 over 15. So 12 over 15 times sine 3t plus 1 over 5 times cos 2t. Okay, so that is the end of the solution for this question. So all you need to do is take the value of p and substitute here. Thank you, students.